So, we had spent a lot of time, a couple of days, looking at a pendulum and seeing how those three factors, mass, amplitude, and length of string, affect the period. After we did that, we moved on to graphing that motion just a little bit, and that's what we went over with yesterday in class, the end of class. And then I asked you last night, here's some other graphs, pull information off of it. So let's take a look at this. The first question was asking you, what is the amplitude of each of these vibrations? What is the period for each of these vibrations? So first off, who can tell me, what is the amplitude? Who remembers? Sebby.
How far it's dropped from the origin.
Say that a little bit louder.
How far it's dropped from the origin.
So how far it's dropped, very close, how far maybe it's moved away from the equilibrium position. We call the position again in the middle an equilibrium position. Right. So, where would you all say on these graphs, let me zoom in just a bit more, so it's easier to see each one. Where would you say the equilibrium position is on this graph? Go for it. 0. Right here in the middle. These are done pretty simply for you. So yeah, equilibrium position right here at the 0 line. So therefore, who can tell me, what is the amplitude? Yeah. 5 what?
5 degrees.
5 degrees is correct. So remember, amplitude is the straight line distance from the midpoint up to one of these peaks, which will eventually define what the name of that is, or down to one of these valleys. So it's 5 up, 5 down. Amplitude for this is 5 degrees. Yes?
Wouldn't the amplitude for all of them just be where the starting point is on the left?
Technically, yeah, it would. But you, in this case, yes. But imagine if the oscillation started here and did something like this. If it starts there, it's starting at the equilibrium position. So you'd have to go over and then say, oh, that's the amplitude right there. Yes?
Wouldn't logically it not go back to like the maximum and minimum like places on the graph because of like friction?
Yeah.
Yes. So part of the reading last night, there was a certain term. Started with a D. Anybody remember what it was?
Oh.
The cameraman knows.
Was it like dample or something?
Yes, damping, or damping. It's basically the idea that as one of these oscillators continues, it's going to slowly lose amplitude because it's losing energy due to friction right up here. A little bit of air resistance caused it to slow down, but most of that energy loss is right up here, right against that. So yeah, what this would really look like over time would be something along these lines, where it would look like this.
Start getting smaller.
And that's basically a product of the friction taking energy out. Why do you think that isn't happening in these examples?
Because it's ignoring friction.
Yeah, we're just ignoring friction. One of the things that we love to do in physics is just pretend it doesn't exist when we're first trying to learn. Exactly. Cool. All right. What is, this is 5 degrees. Should be easy. What's the amplitude here?
It's 100.
100.
Amplitude.
Remember, read the side of the graph. 100 centimeters. 100 centimeters. Exactly. Cool. Next question. What's the period? Someone want to define period for me again? What is period?
How long it takes for one oscillation?
How long it takes for one oscillation. How long it takes for one cycle. So, if I look at this one, who can tell me what is the period right here? Let me get somebody new. Somebody new. Rachel.
1 second.
1 second. How did you determine that?
Because one wave is done by the time you reach a second.
Yeah, so if you see, if it starts here, it swings to the other maximum position, and then back, and that took 1 second of time. Perfect. Could I have picked a different position than the beginning of that to figure out the period? Did I have to pick the start? Yeah.
You could have went to you could have gone from half a second where it's at its lowest back to where it's at its lowest again, which is 4.5.
Yeah, so I could have started at the lowest point, which is at about 0.5, gone to 1.5, that's the same distance, 1 second. Do I have to pick the valleys and the crests? Which, that's the name, which we're going to learn eventually. The valleys and the peaks. What if I started here, at the equilibrium position? What is 1 full cycle there? Now you might be tempted to say
1.4.
forward and back, and that's 1 full cycle, but does that look like 1 full cycle?
It would have to go down and then to the other half, right?
Yeah. If you start somewhere like at the equilibrium, you'd have to go up, down, and then back. Let's see if that's a second. Does that look like it's also about a second worth of time?
Yes.
So, does it matter where I choose my starting position?
No.
No, I could have honestly started right here, and I just have to say, okay, to right here. Basically go to the exact same part on the next cycle, and that's 1 cycle. Why do you think we tend to go peak to peak or valley to valley, though?
Easier.
You got it. It's just easier for us. Don't make things more difficult than they need to be. Occasionally, questions might ask you to start from somewhere, but don't ever make things more difficult than they need to be.